All right. Hi, everybody. If you can just confirm that you can hear us, that would be helpful. We're getting started with our community. Thank you. With our community meeting for gRPC. Just a reminder that the calls are recorded, and we will share the recordings later. So just keep that in mind when you ask questions and things like that. We have a pretty full agenda today, so we're going to try to get through as much as we can. The first thing we want to highlight is the 1.6 release, which you may have seen notices about, but maybe not.
So the Go and C core, or the wrap languages, release notes have gone out for those. The Java builds are available. We have not sent out release notes. We were going to be sending those out yesterday, but then we realized that the 160 tag was wrong. It was not actually what we built. So we've deleted the 160 tag. We've done a new build, which is 161. It's actually identical to 160, but now the tag will be correct. And so we'll see release notes for Java soon.
Great. And so the link and everything is in the working docs, or at least the link to, I think the link to Go is in there. I don't know if I put core in, but everything is, release notes are all there. So if you have any questions, feel free to jump in and ask. That's the big general overall update. Jeff Mendoza, do you want to take over and share your work?
Yes. Can you all hear me?
Yeah, we hear you.
Okay, it says I can't share a screen while the other participant is sharing.
Mark, do you mind not sharing yours real quick so that Jeff can?
Absolutely. All right. Should be on shared now.
Okay, cool.
Yeah.
Okay, great. Can you see my screen?
Yes.
Yeah, great. Okay, so just quick intro. My name is Jeff Mendoza. I'm a developer relations engineer at Google. And a couple months ago, I put together a quick RPM for gRPC. So if you don't know, RPMs are the package format for Red Hat Linux. It's used by Fedora, Red Hat, OpenSUSE, and others. And what an RPM will do is it'll let you install packages without having to build them from source or get them some other way. So for gRPC, for most languages, install is pretty straightforward. You can use the languages package manager that's native, and it might download binaries or build gRPC for you. But for those of you using like C++, the current recommendation is to download source and build it on your machine. So I thought that going forward and in the future, people will want to have gRPC binaries that they can distribute and run without having to build from source. So I went ahead and got went ahead and worked on this RPM. And then RPM for Fedora is attributed to Fedora. It will eventually work its way into Red Hat Enterprise Linux and CentOS, which is probably like the more common environment that people would want to run servers in. So just showing you here, I have right now, I just test the RPM. I upload it to the OpenSUSE build service. It's just a quick way to put up a spec file and have it build RPMs and let people download them. I just wanted to give you a quick demo of kind of what you get once you install it. Right now I have a Fedora machine, and I actually have already everything installed, but I'll show you kind of what you get. So as you see, I have 3 RPMs that were installed on this machine: the gRPC, which contains like the libraries for runtime, the development RPM, which contains the header files and the libraries for build and link time, and then the plugins, which are the plugins that go with the Proto C. And just to show you that, let's see, just so I don't have anything installed on user local or opt. All of the gRPC libraries are built and installed with the RPM. So if you do RPM -QL gRPC, you can see that it included all the gRPC RPMs installed in userlib. And the reason this, just a quick note, this was on Fedora 26 and later, and the reason why it's only on Fedora 26 and later is that has the protobuf RPMs that are 3.0 or later, which is a requirement for gRPC. So yeah, I had some quick notes that I sent out to the mailing list on like just an example of using RPM to get up and going on without doing any building of gRPC from source. If you just install the devel RPM and the plugins RPM, you'll have a full running environment. Then you can go ahead and build the example code. As you can see, the example code builds just fine. It uses the Proto Gen gRPC plugin, and then of course it can build and link all the binaries with the gRPC libraries. So if we look at the server, we can see it's finding all the gRPC and protobuf binaries. So yeah, there's nothing really revolutionary here. It's just exactly what an RPM should be, or a package should be for an operating system, for a library. Looks like it works to me. I'm interested in any sort of feedback. Is this something that is going to be useful to people? Is anybody running gRPC binaries on C++ binaries on Linux? Yeah, is anybody using Red Hat, or is everybody still on Debian? So any sort of answer to those questions would be helpful. Yeah, I think that's about it for the demo. Any questions?
Nice. That's
Does anybody have any questions to follow up? And then you're looking for testers, is that right, Jeff? Yeah,
I mean, if anybody wanted to test it out, that would be great too. I have the RPM available for download from this OpenSUSE, or this Open Build System repo, just to get a double check that it works for them. Would be great.
Awesome. Well, we'll put the links to everything in the working doc. So those of you, if you're interested in playing with it after the call, you'll be able to go and get the right stuff. So we'd love to get some feedback from everyone.
Yeah, and then going forward, I haven't worked on it recently. I'll go ahead and update it to the latest release. And there's some lint issues that I'm just trying to solve to get just the right permissions on everything. And then I can go ahead and contribute it to Fedora and start the process. If anybody is an existing Fedora developer, or knows somebody that can sponsor me for contributing to RPM, that'd be really helpful as well.
Great.
Cool.
All right. Mark, you want to take it over? So Mark's going to do a deep dive for everyone on ServiceConfig.
All right. So here's what I'm going to cover. We'll talk about sort of an overview of what the ServiceConfig is. We'll talk about the sort of structure design in protobuf and JSON of how it's actually represented, how it gets distributed to clients, and then current status and future work. So we'll start with our overview. The goal of the ServiceConfig is to provide a way for service owners to set default parameters for their service. So if you have a server, a service that you're providing, and you want to sort of say, publish, defaults for all of your clients to sort of automatically pick up, this is a way to do it. We've talked about, maybe adding support for server-side stuff later, but right now it's client-side only. The ServiceConfig is returned to the client as part of name resolution, so it's keyed by the server name, not the service name. So if you have an RPC server that has multiple RPC services, they would all be configured through the same ServiceConfig. The ServiceConfig supports both sort of global parameters for the, that affect communication with that server name. It also supports per method parameters. This is sort of the set that was included in the original ServiceConfig design. There's one global parameter, which is the load balancing policy name. This is the way that you select round robin instead of the default pick first. And there's a bunch of per method parameters. Wait for ready controls the behavior of the client channel as to whether the RPC will fail after the first connection attempt to the server fails, or whether it'll keep trying, it'll stay pending until its deadline if it can't connect. The timeout is a way of sort of specifying what your deadline is going to be on a per call basis. And then max request and response sizes. Because we're only checking these on the client side, one is checked as a send limit, one is checked as a receive limit. If and when at some point in the future we start supporting the ServiceConfig on the server side, we would obviously check these on the server side as well. The mechanism here is extensible. Even though this is sort of the set of parameters that we included in the original ServiceConfig design, we do expect to be adding to this over time. The retry design, which I think we talked about in a previous community meeting, for example, adds a bunch of parameters here, and there are other things that will undoubtedly get added in the future. A lot of these parameters that are included in the ServiceConfig are things that can also be set via the client API. The ServiceConfig sort of provides defaults, but you may want to allow clients to override in certain ways. And so there's a need to sort of define what the conflict resolution is in the case where a given parameter is set both in the ServiceConfig and via the client API. And there really are no sort of hard and fast rules for this. It's really, the behavior on that is defined on a per parameter basis. So a couple of examples here. In the case of wait for ready, whatever you set via the client API overrides what's in the ServiceConfig. If the ServiceConfig sets some default, if you explicitly set it either way in a client API, that overrides what's in the ServiceConfig. Whereas the behavior for the timeout field is that we use the minimum of the two values. The intention here was that if a service owner is publishing a config that says, this RPC will time out after 30 seconds, what they're really saying is, I'm not committing my server to actually work on processing a request for any longer than that. And so we don't want the client to be able to sort of override that to a larger value, but the client might say, well, 30 seconds is way too long. If I don't get an answer within 10 seconds, I want to give up. So they're fully able to set the value lower, and that will be fine. So we use the minimum of the two values in that case. So it's the interaction between what's set in the client API and what's set in the ServiceConfig is defined on a sort of case-by-case basis. All right, so let's talk about what the structure of the config is. Now, obviously here at Google, we use protobuf for everything, and we want to be able to express the ServiceConfig as a protobuf, but gRPC itself has always been agnostic of individual IDLs. You could use it with something other than Proto if you want, so we don't want to sort of take a Proto dependency in the gRPC core. As a result, we're using JSON in core, and the Proto libraries have a sort of, a default conversion of any given protobuf to JSON form. So we've specifically designed the JSON form that core uses to be the JSON form of the protobuf that we're using. The JSON form is documented. You can see this link here in the gRPC repo. I never did publish the Proto definition, although I probably should do that in case people want to use it outside of Google. I'll take care of that at some point. So I'm going to go over this in Proto form, but just be aware that in gRPC core, you'll generally be doing it in JSON form. So the main ServiceConfig Proto, basically you'll have any of your global parameters, of which at the moment there's just the one, the load balancing policy, and then you'll have a repeated method config for your per method parameters. So here's what the method config looks like. Each method config has, you'll have a bunch of per method parameters in here, and then you'll have this name field, which has both a service and a method specified. If the method field is unset, then it's a wildcard entry that applies to all methods of the service. A given method config Proto can have multiple names. The only sort of requirement here is that when you have multiple method configs in a service config, you can only have a given name in one of those method configs. So you can't have multiple method configs with the same method name in it, because then we'd have to figure out, rules for like which one takes precedence and, merging, and that would get complicated, and we didn't want to deal with that. So this is the idea. So here's an example just to illustrate this. If you have, let's say you've got three methods, A, B, and C, And for A and B, you want to set wait for ready true, and for B and C, you want to set timeout of 30 seconds. So you might think that you could do it as shown at the top here in red, but that won't work because you actually got two different entries here for method B. That's not legal. So instead, you would do it the way shown at the bottom here, where you've actually got a different entry for each method, where for A, you set wait for ready true, for C, you set timeout equals 30 seconds, and for B, you set both of them. Now, there may be cases in the future where you want to, where there's like some significant overlap of a bunch of different settings between your methods, and you really want to express it for yourself, more like what's shown at the top. And if so, you could express it that way in your own config and then just write a little converter that expands it and generates the data. So I think there are other ways to solve that problem. And as I said earlier, we really didn't want to get into the sort of precedence problems. We think that would be more confusing in the long run. So this is the way we've done it. Here's an example of using wildcard method names. So at the top, we have the first entry here is an entry for service my service, but it doesn't specify a method name, meaning that it's a wildcard for all methods of my service. And the second one is a set of parameters for a specific method called foo. And so the rule here is that the most exact match wins, regardless of what order they are in the config. So if we get a request for method foo, we're going to use that second entry because it exactly matches. If we get a request for method bar, we'll use the first one because we don't have a specific one for bar, and we therefore fail over to using the wildcard one. All right, so that's how the overall sort of structure of the config works. Let's talk about sort of how it gets out to the clients. So as I mentioned earlier, the service config is returned to clients as part of name resolution. Each resolver can have its own mechanism for doing this. So if you implemented your own resolver, you could use whatever mechanism you wanted. Obviously, the resolver that we ship that most people use is the DNS resolver. And the intent here is that the DNS resolver will read the service config in JSON form from a DNS TXT record. And there's a link here to a gRPC that's already been approved and submitted for how this is going to work, and we're in the process of implementing this. There is an alternative to, there is another way for getting the service config into the client directly via the client API, via a channel ARG. This is useful for testing. There are also some cases in which, let's say you're in an environment where you are in direct control of all of the clients and you already have some mechanism for pushing config changes to the client, and you just want to use that existing infrastructure and not build your own resolver implementation that knows how to deal with that. You could use this in that sort of environment as well. We don't necessarily recommend this, but it is available if that's what you want to do. There is also a channel ARG, again, mainly for testing, that inhibits the resolver returning the service config even if one is available. So normally if you specify the service config via the client API and the resolver returns one, we use what the resolver returned, not what you specified in the client API, but you can tell the resolver, don't read the service config, don't return that, so that you can use this one that was specified locally instead. And there's also an API for asking a channel. So let's say you are using the resolver to get the service config, you can create a channel, ask it to connect, and then ask it, show me which service config you're actually using. So this can be useful for diagnostic purposes. One of the things that you often want to do when you're distributing something like a service config out to all of your clients is you want to avoid, pushing a change to all of your clients at once and breaking them all at the same time because you fat-fingered some parameter or something. So the way that we deal with this is we actually wrap the service config JSON in this basically there's like a list of choices here where each choice has a set of criteria that determine whether that choice matches a particular client. So each client that gets this will basically iterate through these lists of choices and stop at the first one that matches the client. And this allows you to do, to basically push a change that only applies to a certain subset of your clients for canary testing, and only once you're satisfied that those clients are happy, would you then sort of increase and send it to a wider set of clients. So here's a couple of quick examples of this. So the first example is canarying changes on a per client language basis. Like let's say that you had a change that you wanted to roll out only to your C++ clients, or or if you happen to have a small number of your clients in one particular language and you want to canary that way, for whatever reason. So the idea here is you've got multiple entries. The first one is client language C++, so only your C++ clients would, they'd read there, they'd see that first one, oh, that matches me, I'm going to stop there, and they'd use that option. The Java clients would not match the first one, so they'd look at the second one, ah, that matches me, I'm going to stop there, and then, Python or whatever else, any other languages would basically look at would not match either of the first two, and so they'd fall back to using this third one. So basically, the last one is one that doesn't have any criteria, meaning it matches everything. In almost all cases, the last entry in the list will be the one that doesn't have criteria. The second example is one where you're canarying changes by percentage. This one is just sort of a random sampling technique. So each client will basically generate a random number between 0 and 100, and if that number is less than, in this example, 25, they'll use the first entry, otherwise they'll use the last one. This is useful for just taking a random sampling of your clients, of a certain percentage of them. It's unstable in the sense that since the client generates this random number, it regenerates that each time it restarts. So when your clients restart, you may not get the same subset of clients using using that particular new version that you're pushing out to this percentage of clients. There are ways that we can, like internally, we have something similar to this where we have actually a sort of a stable way of referring to clients even once they restart using a sort of a unique identifier, essentially. And we can talk about doing something similar like that for the OSS implementation if need be. But right now, this is what we support. All right, so that is the distribution mechanism. Let's talk about our current status. In C core, the core support itself for ServiceConfig is done. The DNS resolver support is still in progress. There are actually two DNS resolver implementations in C core these days. The native DNS resolver, which is still the default, the one that we've always had, which basically just uses get host by name. It uses the normal Unix resolution libraries, but because it's doing that, it doesn't have access to things like TXT records. So that resolver will never be able to support service configs in DNS. We have an alternative DNS resolver that is currently still not the default, that's based on the cRPC library that goes out and talks to DNS directly. And it does have support for reading service configs from TXT records. Eventually, we do want to make the cRPC resolver the default, but there are a few things that are still missing that we can't switch it over yet. In particular, it doesn't quite have CNAME handling correct. There's some address sorting stuff related to IPv6 that isn't there yet, and there are some problems dealing with DNS TCP responses. We do plan to fix all of this, but that's still in progress, and so until then, this is not the default, but you can select use of this resolver using the environment variable gRPC DNS resolver equals areas. And so if you want to test this out, you're certainly welcome to do so. In Java, the service config work is scheduled to be done by the end of Q3. And in Go, the work is in progress. There's some other work in Go that's not directly related here. There's a sort of a major API redesign in progress related to the balancer and resolver APIs. And that work is sort of a prerequisite for getting the service config stuff fully available in Go. So this is likely to slip a little bit into Q4, but it is actively in progress. Some future work here, as I mentioned earlier, as we add new features, we will undoubtedly grow the number of parameters that are supported by the service config. The retry design definitely adds some stuff, but we've talked about things like heap live parameters and maybe some flow control parameters. A lot of this is speculative, but there are definitely, you should definitely expect to see more parameters be added here over time. And we've also, as I mentioned earlier, considered maybe at some point in the future adding some server-side support so that parameters that apply to both sides, like the max request and response size, could be used on the server side as well. That's it. Questions?
Everybody a minute to unmute. If you have a question, feel free to unmute yourself and just ask away. Perhaps it was so comprehensive that we're done. There are notes in the working doc. I'm guessing that highlights are there if anyone has any wants to go back to it for reference, and then we'll also have the recording, of course, available later today. So, and feel free to, if a question comes up, feel free to type it in and ask away. Okay, otherwise, we can switch over to the working doc, and there's a bunch of questions in there. It looks like some folks were responding right away, but maybe not. Let's see if I can pull it up here. Are any of you on this Hangout?
The Zoom one?
No, just this random number Hangout.
You can join it.
And that way, because I have to share the Zoom.
Okay, yeah.
So someone can share the doc. But the first question was from Arpit. Do you want to unmute and just ask in person?
Yeah. Hello. I submitted a few questions actually. One of them was regarding census, and all my questions are for C++ stack. I see there is code in there, but I don't see like I tried it at runtime and nothing like really worked. So, and I looked at the pass thread. It wasn't like clear to me that what's the plan. Especially, it would be nice to see it being referenced like stack-wise, because a lot of times there is confusion around which stack is planning to implement and at what timeline. And others are, the second question I had was that there were some options that were repeating regarding the idle cleanup. I tried them and they seem to have some crashes, and I filed just bugs in there. I don't think we can discuss it on the spot, but I just referenced those bugs there. And the third question I had was like when we use the async API, the OK bool. I think this question is also posted on the mailing list very often, so it would be nice to get a comprehensive talk. I think in some situations it's very easy to understand what this Boolean means, but there are some situations where it's just not clear and it's not documented. So that's all I had. Thank you.
Okay, so excuse me. I know we get questions about census a lot. Does anybody have anything more other than?
I think the request is valid, right? Like, timing and stack is the most valuable thing we can probably say. Isn't Java like the furthest along? No?
Furthest, we're pretty far.
Pretty far, right?
With census. Yeah, so I'm forming with release notes. Tracing is enabled in 1.6, but we're still working on stats. I expect some of that to still, and I wouldn't expect C to be too far ahead, even if they are.
So
I thought there was some discussion that the time frame from the census team was that for all three languages, I thought they were really aiming at having open source stuff. Or I might be wrong about that.
yeah. So Java, definitely, I think we can get. Will be by Q4. We'll have both. Tracing is down, but like stats and
Stats is progressing quite well. It's quite close now.
Okay, so
it's the final things are still being done on it.
C core Go. Does anybody have anything more granular? Go and census,
No, I haven't heard anything.
No? Okay. So I think RAI is just like give some timing.
It might not be a bad idea, like just going forward to make sure somebody from census team is here in these meetings, because we get a lot of questions about this. So none of us here can really answer them authoritatively.
Yeah, we can.
Okay. So I'll take.
They've popped into a couple of other online discussions, but it's been the same kind of answer of like we don't have a definitive timeline yet. So I will definitely follow up and try to get a more concrete answer for everyone. So the second one was about some GitHub issues.
Hi, I'm here. I can talk about it.
Oh, sweet.
So this is about an issue with the Python gRPC client. And basically the problem is that every once in a while, the client just seg faults when your interpreter is shutting down. So, whatever you're running doesn't actually exit cleanly. So the reason I bring this up is because I reported this about 6 weeks ago. And unfortunately, I don't have a good repro because I suspect what's happening is there's a race at shutdown and the completion queue is like polling and there's a request coming in, but the channel's already partially shut down. But I'm going to untangle this RPC code from Dropbox code, so I can't give you a reproducible test case. But it seems like the issue was sort of tagged as a UX P2 something, and I was kind of wondering about the reasoning going into that and whether that's something that is being looked at, because I'm pretty sure this is going to affect other, consumers of the Python client as well.
So we're pulling it up now.
So I looked at one of them, the other one.
Not this one.
Oh, is he talking about?
I was talking about the Dropbox.
The Python.
Oh, Python client.
Yeah, only quite finishing for this one. But.
Yeah, we didn't address Arpit's other two questions. So, but anyway, now that he spoke, let's do this and then we'll go back to that.
Yeah.
So on 1.4 Python. So looks like Nathaniel to say what.
Yeah, so I got factors in UX clause.
Yeah, on August 1.
And there wouldn't have been much movement on it in that time frame.
Okay. Hasn't been assigned. Okay, so we need to come back on timing, priority of that.
Yeah, we can retag it.
Can you help us reproduce it in any way? Like, it looks like.
Well, the most reliable, can you hear me?
Yeah.
Yes.
So the most reliable place where I see it as being reproduced is in our build server, as is doing RPCs to push out finished build artifacts. So yeah, I don't really have a great test case to give you, unfortunately. I have one idea of what it could be. I'm going to see if I can give you something simple, but it doesn't just because I can get a test case doesn't mean this bug isn't worth fixing. Maybe someone else will give you a better test case. I don't know, but.
Okay. Without reproducing, it doesn't seem like we have a cause. Yeah. Okay, David, I don't think we can give you any update here. We'll tag Nathaniel and update the doc.
Okay, thank you.
Let's go back to Arpit's other two questions.
Yeah, sorry about that.
No worries.
Well, one of them was documentation, which we can add that to our list of documentation that needs to be updated, or ideas for documentation that we should add, since that was a ask from the last
That's C, right?
meeting. Yeah.
So B, does anyone here know? Arc max connection, server freezes randomly on completion queue. Open these now and save it down.
Yeah.
I think that's fine. I mean, these two issues, I see them recently being assigned, and I think as long as I guess it can be reproduced or it can be looked at and verified that yeah, they are legit issues, that's fine. I don't think we need to talk about them here. So.
Okay.
But I just wanted to bring it to the attention. Yeah.
Yeah, just keep poking us if you don't get some sort of movement on it.
Yeah, the max connection age stuff, or the max connection stuff looks like it's still sort of being routed.
Yeah, I
Because Craig is probably not going to be the final person.
Yeah, I think I seem to recall Yuchen wrote this code originally, and he might be the right person to, yeah. In fact, I think I'm going to reassign it that way, because
I don't think Craig will mind.
yeah.
Okay. First step, we're assigning to the right owner.
Okay. So Luke, you had some questions, and it looks like you had some answers typed in, but I don't know if it covered everything for you, so let us know if not.
Yeah, there's only one last bit there, which was, is there a way to shade gRPC Java and Proto Java, including generated code?
Including generated code.
Yeah.
If you know all the package names for the generated code, I think that would just work.
Yeah, but one of the things is that, like, looking forward to the 1.7 release where you'll have Netty and TC native and that kind of stuff shaded away.
Yeah, so Netty, problems with Netty and its unstable API that we're using, yes, that lots of people will be able to use the pre-shaded artifact. That should help considerably. And then, but as far as protobuf, I've not heard of too many shading problems with protobuf.
Even if you use like sort of reflective descriptor stuff.
I'm thinking most of that doesn't do class.for name stuff. I don't think that would be confused. If there's if you tried it and it doesn't work, I'd be interested, and you can CC me on a bug to either protobuf or gRPC Java. I'm eJona, I guess eJona 86. But I think I know of people that are shading protobuf, and I've not heard of any problems there.
Okay.
There have been more details. In order to shade gRPC Java, you need to your shading mechanism to know about services and to properly shade the services, which Maven shade plugin was messed up for a while. It's now fixed. The Gradle shadow plugin looks like it's fine. I've not checked jar, but if you're having trouble there, I'd still also be the person to investigate some of that.
Okay.
The last problem that I was aware of is TC native was not shadable, and that was fixed. I'm just going to make up a number. Let's say 2 months ago, upstream, and then then there were some usability things that were still a little bit painful for people, but it was possible, but painful, and so those are now resolved as well. So I'm not aware of any present shading issue with even 1.6. It might be a little painful, and I can help you with configuration though.
Okay. And then if I had control over the user's class path and was able to make sure that the gRPC Java, protobuf Java, Netty, TC native all were the correct version together, and you're saying that even if the person generated code against an older version of gRPC or protobuf, it should work.
Yes, and this is very, very important because you are going to have older versions of gRPC generated code sort of mixed in with your class path, and it's close to impossible to require all of your transitive dependencies to build their generated code at the same version. And so yes, we really need to support old generated code with new runtime versions.
Okay.
Now, if there's some new feature, it may not work as well, or it may not work, but that's sort of to be expected. But the older code working on the older version should still function.
Okay. Thanks.
All right. Any other questions from anyone? All right. Well, if anything comes up, by all means, add it to the working doc or reach out on the list, and we will get a response for that. Thank you to our 2 demoers today. Much appreciated. And if anybody has any questions or anything else comes up, please ping us. Otherwise, I will share this out when we have the recording, and you can share it with everyone else. Thanks, everybody.
Thank you.